Hey guys, it's all around Danny, and this is a video showing you guys how to find the determinant of a matrix. So first of all, we're going to find the determinant of a 2x2 matrix, and then I'm going to show you guys how to find it for a 3x3. We can also do this for a 4x4, 5x5, and so on and so forth, but it would just get a lot messier and a lot lengthier, so I'm just going to stick with the 2x2 and the 3x3. So what we simply do is that we're going to multiply our numbers diagonally. First of all, we multiply the upper left-hand corner times the lower right-hand corner, and then we put it like this, 2 times 4, and then we would minus whatever the product of our upper right-hand corner times the lower left-hand corner would be. So it would be 3 times -1, so then this would simplify out to 8 plus 3, and our determinant would be 11. Alright, so you guys really need to know how to find the determinant of a matrix in order to do different things, such as finding the inverses and finding the area of a triangle using matrices. So this is a really important concept to understand. So you might, if you guys want some more practice, we're going to do another one. 3, -1, 4, 5. So you guys go ahead and do this one, and I'm going to do it along with you. So you guys should have gotten 17. And now we're going to move on to a 3x3 matrix. Okay, so when it comes through a 3x3 matrix, the process is a bit different. What we have to do is that we have to add 2 other rows from the matrix that we already have. So let's just give this 1. Okay. So what we do here, we add these 2 rows to the right side of our matrix, just so we can multiply diagonally correctly, because if we end it here, there's nothing to multiply diagonally, so we have to add this row. Now if it was a 4x4 matrix, 1, 1, 1, I'm just going to make it ones, all ones. As you can see, we would have to add more rows here, so we would add 2 once again, just so we can multiply, pardon me, not like that. We can multiply diagonally like this. Right? Oh my god, I do this horribly. So we can multiply like that, like that, like that, and like that. So we have to be able to multiply diagonally by how many rows the original matrix has. So we would simply add 2, and that applies for every matrix after that. 5x5, 6x6, so on and so forth. So now we would simply multiply our numbers once again, starting from the upper left-hand side, and then minusing it by the multiplication that starts on the upper right-hand side. So we're going to do is we're going to go like this. So this will be 1. So it'll be 2 times -4 times 1 plus this row, which would be -2 times -3 times 3 plus this row, not a row, pardon me, just that diagonal section, I guess I would call it, times 5, and then we would minus the sections going the other way, so it would be -2 times -1 times 1 plus, going like this, so it would be 2 times -3, actually, yeah, 2 times -3 plus this section right here, so this would be 6, I believe that's a 6, yes, 6 times -4 times 3, and now I'm going to give myself some room here, so I'm going to delete the original matrix. So we would get, give me a second. Okay, so now we would simplify this out to 2 times -4, -8, plus 2 times -3, that would be 6 times 3, 18, plus 6 times -1, -6 times 5, plus negative 30. We can just cross that out and make it just minus 30. Ooh. Put that in parentheses because we have to do this order of operations first, and then minus whatever we get on whatever the other thing was right here, down here. So now it would be negative 2 times negative 1. It would be 2 plus, let's put the parentheses first, 2 times negative 3, negative 6 times 5. So it would be plus negative 30. That would just be minus 30. Plus 6 times negative 4, negative 24, times 6, negative 72. So it would be minus 72. So that right here, let's just simplify this out. Negative 8 plus 18, that would be 10, minus 30, negative 20. Minus 2 minus 30, negative 28, minus 72, it would be minus 100. So our final answer would be negative 120, and this would be our determinant. So that's really it when it comes to finding determinants. But one thing that, one thing that we have to keep in mind when we're doing determinants, if we have a matrix like this, let's say 2, 2, 2, 4, 1, and then when we multiply this out, 2 times 2 minus 4 times 1, so this would be 4 minus 4, our determinant would equal 0. That means that this matrix does not have an inverse. That's very important when you're trying to find inverses and solving different types of matrix equations that have to do with inverses. You have to keep this in mind. The determinant cannot equal 0. If it does, that means that it's simply not possible to find an inverse. So that's really it, guys, when it comes to finding determinants of matrices. Thank you guys for watching. I'll see you guys in the next video.